engineers have figured out that there are lots of different proteins, and this, like this blue thing, is more than one protein, this pink thing's more than one protein. But they come together as complexes. So we call this one complex 1. You can purify this one by itself. If you disrupt this membrane with some detergent, if you do it carefully, you can get this as one unit, this is another unit, and so on. These units, so there are 4 of them, 4 complexes, and they each have a specific job in this process. Complex 1 is where the electrons start, NADH on the inside of the mitochondria, donates a pair of electrons to it, and its job is to take the electrons from NADH and move them to this molecule Q in the membrane. So hence its name, NADH coenzyme Q reductase. Complex 2 takes electrons from succinate and a pair of electrons and moves them to Q. This is a detail I didn't mention before. When we talked about the Krebs cycle, if I could just dash back to that for a second. This enzyme right here, succinate dehydrogenase, it's one of the redox enzymes in the Krebs cycle. This one is different from all the other enzymes in that this one is actually buried in the membrane. The rest of these enzymes are soluble enzymes that float around in the liquidy matrix. But succinate dehydrogenase is a membrane-bound enzyme. And in this context, there it is right there. We're calling it now complex 2. This is succinate dehydrogenase, donating its electrons directly to.
So it acts both?
It's the same thing. We're just calling it different names.
Okay.
Complex 2 is succinate dehydrogenase.
Mm.
But yeah, so it's.
The
what
other
I'm saying is it sounds like some of the other enzymes are just specifically for the Krebs cycle.
they're in here. The Krebs cycle is happening in this
Yeah,
liquidy
exactly.
phase here. So isocitrate dehydrogenase and everything would be happening in this phase.